as you know, we started with 3D printing quite very early by making our own machines. And very soon we realized that unless the machine is getting used in the industry, it's not going to be something which everybody will use. So what we did was, we started innovating how to use the machine in the industry. And that time, as he said, the jewelry was one of the sectors which really required this machine, because karigars would make one or two things by hand, and that was not a very good earning point for them. So we used SLA machine, which is a liquid resin based machine, and we used wax resin to cast metal parts out of that. That is the first introduction that we did when we started with SLA. And we realized the need of metal printing quite early. Apart from metal printing, we also started doing ceramic printing. So we did a lot of research in bioprinting in the past, and that's how we started. Today, you can see a lot of karigars actually using the machine rather than people who are trained or professionals. And that is a very good turning point as well as industry is concerned. So, since about 5 years, we have been working on technology to reduce the cost of metal printing. And we recently launched our filament-based metal printing option. So we're going to teach you everything about that today. How many of you have actually experienced 3D printing in the past? Have any of you printed with a 3D printer, or none of you have printed with a 3D printer? So have you seen like a 3D printer working before? Yes, he has seen. So basically 3D printing is layering parts on top of each other to create a part. So you take any kind of thing, whether it can be a food item, or it can be metal, it can be plastics, it can be resins. When you layer them on top of each other, then it's a 3D printed object. Okay. If you see a CNC machine, what do? We take a plywood and we cut it, or we take a metal and we cut the sheet with laser. You can think of it like one layer of the 3D printed item. Now, you can't, when you are cutting something, which we call as destructive manufacturing, when you cut something out, you can't control what's inside the body. So why is 3D printing so important? Because in 3D printing, we can control the inside structure of the body, molded part and sintered part. What happens after this molding process? You can put the material back if the molding fails. But after the sintering process, you can't put the metal back as a metal powder. It has to go for recycling. Okay? Another drawback of this system is, if you make any parts, it's 100% solid inside. You can't actually make the internal structure. And if you see internal structures, can save you about 70% cost of material, because you can get the same strength by making a lattice structure inside. So like a honeycomb structure or some kind of a structure inside to get the same strength of the part. Okay? Another problem of injection molding is you can't create grooves or cuts in many places, as the molding has to open and part has to go down. So you can't create a lot of different faces or cuts. It's a very straightforward process. So that's another drawback of the current system. Now let's look at the casting. What's happening in casting is, you make a part, you put it in the mold, that mold basically is put in the oven, and the part is usually made up of wax. It falls down, you fill it with metal or whatever material you want, and then you get your final part. Another thing is, again, it's a solid part. You can make a lot of faces, but it's a limitation because you need a setup, you have to be trained in casting. Casting fails very fast because if you make even a little bit of error in the process, there will be cracks or minor pores inside the casting part. Then it's sand casting. So sand casting, if you see, again you make your part, it goes into a mold, which is a two-part mold. You create a cavity, you pour the metal, and you get your final part. So in sand casting also what's happening, it's 100% infill inside. It's there's a seam line on the sand parts, if you see, and that seam line has to be clean for every part. Okay, so all these processes are basically now leading to more work. There is extra work when it comes to doing this. So and also if you see all these processes, they require professionalism. They require a lot of attention of the person making the part. Because if there is an error in creating the mold, it will lead to a defect in the part itself. And in most of the industries, if you see, they will create oversized parts and then it will go in a lathe or a CNC machine to be finished. Okay? So that brings us to 4 types of technologies when it comes to 3D printing. One is powdered metal or ceramics. So what is powdered metal or ceramics? We take powdered metal and we layer powdered metal in a very fine layer. Then we use either laser or we use a binder to join those metal particles together. And these layers are 10 microns or 5 microns layers. So they are very fine layers and they are melted or joined, binded by specialized machine, layer over layer. So now if you imagine yourself in 2D, you can actually create internal structures and the whole part is created as one piece. There is zero wastage because the part which is left unbinded can be reused again. Okay? I'll just show you a short video of how this works. इसको कैसे चलाते हैं? स्केल कैसे करते हैं?
Right. Yes.
फुल स्क्रीन कर सकते हो?
डबल क्लिक कर सकते हैं.
डबल क्लिक. वॉल्यूम बढ़ाओ.
वॉल्यूम चाहिए सर.
So this is our machine. It's called Aurora Labs. It is a desktop metal printer which runs on powdered metal. If you see the machine, there are 3 hoppers on the top, which allow you to put 3 different types of powders or metals powders on the machine. So you can actually simultaneously print 3 metals technically. Then there is a chamber, and that chamber is basically used for making the part. It's a vacuum chamber and it has argon gas inside, so the part doesn't get oxidized. We all know metal gets oxidized if you fire or make it hot at certain temperatures. Now what happens in this is, once you start printing, it layers a very fine layer of powder, sinters it using laser, then puts another layer and sinters it. It's like, imagine yourself taking welding and welding a layer, then another layer of weld, another layer of weld, and then you get your part. Okay? But we are welding using very fine laser, and that particle is very fine. So it creates a solid part which is 100% solid. You can create hollow structures inside, and it's very fast actually. नहीं आ रही है
Sound, sir.
साउंड नहीं आ रहा इसमें. So one of the very first uses of this technology was to create statues. So a bit of a statistics here. In India, a lot of god statues are sold. Typically in a year, we do anything from like 40,000 to 50,000 types of gods in India. And that's just gods, okay? So if you saw the process, these are very, very fine powders. It's almost like 500 micron size powders. It's laid on a bed. The laser goes, fires it. The next level is formed, and so on and so forth. Okay? There is a wiper to wipe out excess powder from that layer. So everything is happening in micron layers. So this is like a heap of powder which is left after the machine finishes, and you have to manually remove it. You can also use a specialized vacuum machine for removing all the powder, and it's 100% reusable. You just put it back in the hopper and you can reuse it next time. So I'll just go back a bit, and if you notice where the pointer is pointing out, this part, these are structures which we have to put to support the part when it is getting printed, and that also helps in removal of the excess heat. Because it's using laser, it's running at around 1800 to 2000 degrees centigrade. So you have to remove all the excess heat from the metal which is getting printed, otherwise it will start to warp. So if you see in the plastic also, it starts to bend when you heat it, and that's the importance of So that's the part. This part is actually about 40 to 50 millimeters in height. So it's really, really small part. There are lots of details which you can see in the parts. Like if you really notice this part, you will see that there are indents in the clothing, and after polishing you can actually see every line of the clothing. There are certain flowers over here which are not actually very clear in the picture, but even such fine parts are created out of this. This statue is actually hollow from inside, it's 100% hollow. And that is the beauty of it, because this type of a thing is originally made in the industry, the traditional industry, for about 50 to 60 grams. This one is just about 10 grams, the whole structure. So back to powdered metal ceramics. These are all the parts which we have printed in the past. Most of them are industrial parts, and most of them belong to people who are making turbines or heat exhaust systems or blades, lots of things. So all these parts that you see in traditional industry, this sort of a thing is not possible, where the metal is cut along a particular axis to make specialized vents. And if you look very closely inside, you will notice that the veins of this particular blade is not straight. They have a shape, like a window shape, crescent shape they have. All these parts are not possible for specialized, without using these additive manufacturing. These designs were not possible before using the traditional technologies. Lattice structure like this, where it's completely hollow from all sides, were not possible initially. And it's not just hollow on the sides, it's hollow on the interior as well. So imagine the surface area which this particular company has claimed through its design. The future of radiators basically look like this, where you will have hollow, the liquid running from inside, but there will be more surface area because of a mesh-like structure being created throughout the part. So another thing that you can do is control the angles of the shape. In traditional industry, you have to work according to the limitations of that industry. But over here, it's virtually you can print whatever design comes to your mind. There can be some challenges, but over time it's getting wriggled out. Most of the challenges are getting wriggled out. There are now new methods of doing the same thing, and you will find yourself, adventuring out into a place where literally what you think and what you can design will be a reality. What this sort of a thing allows you to do is not only print a part, but even test your concepts on small scale. Because when we talk about CNC, when we talk about other technologies, there are limitations in terms of size also. We can't go nanoscale. Nanoscale machinings are very expensive, not accessible to students or hobbyists or prototypers. But today you can just go to any 3D printing lab, give them your design, and they will be able to print for you at very small scale. And our quantities are one is our quantity. So if you go to a traditional manufacturer, you will say, I need at least 1,000 pieces or 10,000 pieces to give you that price. But here, one is the quantity that we talk about. So you can literally print something, test your concepts, and refine your theory and re-prototype. Plus, all the prints can be sent back to a recycler to be made back into powder. So there is virtually zero wastage when we talk about additive manufacturing. Lost wax or wax casting. So that is another area where innovation is very important in terms of additive manufacturing. Even though it is very close to the current technology, but there is a lot of difference. If you see a jeweler, if you see dentistry, if you see lots of occupations, what is happening is these people can only make a few items by hand, and not too many people are skilled in making artwork. So if you see a normal potter, for example, he is good in his pottery, but you and I are not very good in pottery. We can't make a pottery design. So what can we do? We can simply design it on the computer and print it on a printer. And we'll get the same design output as this. So this has helped in changing the jewelry industry a lot. Because today, you can simply feed the design into the machine, and anybody by press of a button can keep printing it. And 90% of the industry that you see is just repetitive work of printing. Okay. Another thing that was happening is, even if they wanted to print one or two jewelry designs, they had to go through the whole molding process, which means they had to first make the design in wax, then make a silicone mold out of it, and then they could make multiple pieces. And there were limitations, because if I had to make two pieces or three pieces, it used to cost a huge amount of money. And there's a lot of wastage in terms of time. Time is very expensive for a person like a karigar. Okay. So now what you can do today is simply print the part on any machine, whether it is a FDM machine, whether it is a SLA machine, or whether it is binder jetting or any kind of technology, and use that to cast. So we have special casting filaments, we have special casting materials that are one-to-one with the current technology. So the technology can also be imbibed into current usage. And for small scale producers, for small scale manufacturers, it's a very, very good thing, because now they can just take your design and say, I can convert it into a pure metal or a pure piece in traditional way. So they don't need to buy anything extra, they just need to put in the machine for printing your designs. Okay? Another thing that you see is mold gravity creation. So, why spend time making a mold when a machine can make that for you? So, these are high temperature ceramic blocks, and it's simply printed on a machine. So, if you actually go to a traditional industry, first they have to make a masterpiece, then they have to create mold blocks for every part of that masterpiece. Then it goes for casting, it goes for validation, then it can go into production. There is a huge cycle from actual prototyping to production. It can go anywhere from 2 years to 5 years. We have completely cut short that process. So now you simply create the mold, and this mold is from your design on a CAD, so it is absolutely accurate to the final part. So rather than you doing all the work, the computer is doing all the work for you. All you have to do is think on developing your part, and the mold cavity happens by itself. Okay, so I'll just show you a short video on how this machine works. So this is Ceramo. It's a ceramic printer, and it can print about 8 types of ceramics now. But it's totally open source, which means you can put any ceramic, porcelain, or such material, and you will get a print. So what happens in this machine is, you put fine ceramic powder of whatever you want to print with. You can make a food grade ceramics, you can make high temperature ceramics, anything. It can be a very high end ceramics for making spacecraft parts, does not matter. You just put it in there. It uses a binder to bind that ceramic into a shape, and then you put it in a kiln, fire it to make it a proper part. Okay, so the firing process is old, it's getting used since thousands of years. It's a well-known process. All we are doing is binding it using technology. And you can bind almost any kind of ceramic powder in this machine. It's a very fast machine. So very soon you will be seeing a lot of your cups, plates, and other things getting printed on this. That's Ceramo. Now let's come to the another important aspect, which is metal ceramic binding printing. And what is this? So I told you, you take any kind of binder and you mix it with a powdered metal or ceramics, and it forms a whole new technology. We saw MIM, which is a traditional technology in which a binder was used to print with, and then you do the casting, so you get a part, right? We are using almost the same, but in this, instead of using two types of binders, we are only using one type of binder. So this is called filament, or short form for metal filaments. This technology is available in our institute now. What happens is, it's 90% metal, 80 to 90% metal, with 10 to 20% binder, depending on the metal and the compound. You simply print it like a PL. So because most of you have not printed before, I hope you will understand. You will have to try it out once. But it's very easy to print it. Everybody must have used glue gun, right? It's just like expressing a glue gun out. So imagine a machine like a glue gun, and it's doing the same job. It is that easy. Now imagine the power of this technology. Even a 9-year-old can print in metal. All he has to do is insert the filament in the machine, put his file, press a button, start, and that's it. So, and it's very, very inexpensive to use these things. And the applications of this technology is far more greater than we thought about. Just not metal or ceramics, you can do any kind of earth materials, whether it is marble, rocks, glass, any kind of metal using this technology. You can do radiation shielding. When there's a cancer patient and he goes for radiation therapy, they actually put a piece to block all the other areas, and they leave a slot just for the radiation to pass through where the cancer is. So the block that is created is called a radiation shield. It's getting used in the hospital. This technology can create the radiation shield customized to the patient. Because right now, they only take something like a foam block, and they almost have most of the shapes, so it's like a puzzle, you fit something and then they just do it. So it's not actually matching the customer's profile. And a lot of time, post-treatment, patient has to suffer because of this. Because the areas which were not originally having cancer, you will see that sometimes it spreads or there are defects in the treatment. And that's because of the technology. And abroad, now we are actually kind of patenting this technology, and we are testing this technology with a lot of hospitals and getting it FDA approved. So you can actually use it on a patient. All you do is take the patient's profile, print a specialized radiation shield for him, and it can be used on any traditional radiation machine. Another very big advantage is, because it is having a plastic infused metal, you can actually use it for EMD or electromagnetic safe devices. You can use it for blocking wireless transmission and a lot of other activities. These are very good as lead blocks. These applications were not before. They have started getting used now because of the composite binding technology that's come into play. One of the biggest applications of this is in the statue industry. Because typically in the statue industry, the customer wants to see the part and how it looks before they purchase it. And sometimes it can take a very long time to make a marble statue. So using this technology, what you can do is simply print the part, polish it, and it will become immediately as if it's an original marble piece. It's only 10% binder, so you never come to know that it's not pure metal or it's not pure plastics. And for aesthetic looks, it's just like the original marble or original metal for that matter. So it's very easy to get your customer in the decorative industry, you know. And then you can simply throw the piece into a recycler and get your filaments back. So it's zero wastage, and you've got an order from the customer because you had a piece which is a look-alike of what the original will look like. So in the prototyping industry, it's becoming really, really famous, especially in the decorative items industry. You know, another thing is it feels just like the original. So if you see a metal particle which will show you in the lab, it will feel just like the original. The weight will be the same. It's only 10% binder, so you don't really come to know the difference in weight. It will emit some of the properties of the metal. So if you even see the unsintered piece, it will still have electricity, conductivity, and other things. So it's very good for testing, immediate testing of blocks, where you want to check the dimensions or the fitment or something, and then you throw it in the recycler. So it's in the green state right now. Once you put it in the furnace, then it will become pure metal, and it will just stay like a pure metal. So you've not only got a part to test, but also a part which can be used in the industry just from one print. And once you make a design, it can be replicated many times. So that's one of the best advantages, because you don't have to be dependent on somebody with skills, to do that for you. The machine has the necessary requirements to repetitively do it in a precision all the time. So rather than from skill-based industry, we are moving towards technology-based industry, where machines will do the repetitive work for you. So we have in this, for example, bronze, copper, stainless steel, titanium, ceramics, lots of types of clay. Dental industry is one of the biggest customers that we are trying to capture with this, because you have zirconia silicate metal powder also now. And you can simply print somebody's teeth with a sinter it and put it. It's that easy. So we are moving ahead, from thinking about the technology to the applications, and that is what, as a student or as researchers, we need to do. We need to move away from the actual thing to the usage of that particular research or that technology, and that's where it will actually get more value, because you have an application, right? When I showed you the printer which does ceramic printing, we have another printer like that. I will show you the video in the next session, where you can actually print tablets, edible tablets out of that machine. Even though it is a plastic machine, it is getting used by a lot of medicine companies for trying out specific tablets. So these are the applications which we are developing with these technologies. So at the end of the day, what it is a powder, any kind of a powder with binder. So if you take medical grade binder, plastic, which is actually a medical grade plastic, edible, and you take medicine, you can actually create a filament which is printable on a machine, and that's it. So you don't need to go to a medicine and say, I need 10 grams of, tablets have grams. And even if you need half the quantity, you still have to consume one tablet. Or sometimes you break it, which is not really the correct method. So again, we are trying to move away from the traditional manufacturing to need-based, customized manufacturing, where not in, like just about 5 or 10 years down the line, you will go to the pharmacist and they will have filaments of all your medicines, and you just say, this is my prescription, and they will actually print a powder, tablet for you. So you're not overeating medicines. In India, we overconsume medicines. Abroad, if you go abroad and you ask for medicine, it's a very difficult process. It's not like you go to the counter and say, proceed, and you get a proceed. Then you have to go to a pharmacist, and only if your doctor has written it, you will get it. Off-the-shelf medicine is just limited to certain mild painkillers and anti-allergy drugs and other things. So here, if you go to India and you say, I need an antibiotic, you can get it off the shelf. In abroad, that's not the case. It's a very different concept out there. So they consider eating medicines as really, really a harmful thing for your body. and they want the medicine to be reduced to what the body actually requires rather than what the industry can produce. And this revolution is a very, very big thing in that area. Another very important case study that we are doing is food printing with this technology. So again, it's a food powder and binded by edible plastics. So once you cross a certain age or certain times when you have certain illnesses, people are not able to consume or chew food. Okay, and these illnesses actually prevent them from eating, and they get malnutrition. Or there are certain hindrances people have which hinder them from eating certain types of food. So again, food can be printed or sent to those places like a filament, and it can last for about 30 years with that technology. And once you print it, you can simply eat it like a medicine thing, and you will get the nutrition back in your body. So there are some very important research which is going on around this particular technology. So how does the metal ceramic printing actually work? So in the forefront of this technology, there are two companies which are now like the leaders. One is a very old technology, BASF, everybody knows about them. And the new one is the virtual foundry. What you do is simply make a part and we slice it using specialized software. Again, because most of you have not used Cura before, I am not using Cura, but Cura is the software that we use to slice it. It gets printed on an altimeter. Then, depending on which company's filament you are using, it goes through two technologies. If you are using ultrafuse, it goes into catalytic debinding, and then finally into a sintering oven. If you use the virtual foundry, it simply goes into the sintering oven after print. So this is like a workflow. So you take the filament, make a part, print it, debind it, put it in the sintering oven, print it, put it in the sintering oven, and then you have a metal part. It is that easy. So you can continuously print it, continuously debinding it, continuously putting it in the sintering oven. And just before the sintering oven, 3D printing part is something which is so easy that even children can do that. It's a really, really easy process now. So now, why we say Industry 4.0 again is because in the future, parts for workshops will not come through a distribution chain. You will see workshops where 3D printers will be kept. Suppose if I need a certain part for my machine, I will simply go to the computer, go to the company's website, order the part. The company will authorize a print for that part on the printer. We'll print the part, put it in the furnace. Even furnaces are becoming intelligent. They will get their data how to print, furnace enter it, and they will get the final part. So that's called digital footprint. And there are lots of companies and case studies around it where now 100% 3D printed parts are getting used in creating parts for the customer. And the printing is actually happening at the customer side, not by the company. It is happening at the customer side. One of the famous case studies is Lackway. So in their production line, the shape of the bottle changes almost every 2-3 months. And they used to spend a lot of cost in changing the tools for gripping the bottles in their run line. That is 100% now 3D printed by Ultimaker. So it's a special plastics 3D printed on Ultimaker. The grippers are manufactured in Germany by a company which supplied them the machine. They send the digital file to the printers. It gets printed, and they simply have to put the printed part in the machine. And every 3 months they can change the bottle shape. L'Oreal is doing the same thing. Volkswagen, if you see the Volkswagen study, it's online, on YouTube, everywhere. Volkswagen used to spend billions of dollars in creating very, very simple thing, jig fixtures and tools. So when they used to put their logo on the cars at the end of the factory line, That tool itself costed about 30,000 euros, which they are printing now for under 1,000 euros. So all around the world now, they can simply say, put a 3D printer, these are the materials that you need, all the files are sent to the respective centers for making aligners, jigs, fixtures and tools. All these case studies are there, you can see. For example, if you go to the KLM website, you will see a case study where they are using plastic bottles to recycle all the plastic drinking bottles which customers use during the flight to make repair tools. So this technology is actually getting very, very popular now with industries. Okay? They are saving thousands and thousands of dollars with these technologies. So again, explaining the process to you, you print, you polish it. It's like a very mild polishing that you can do. Or if you don't like the print, you recycle it. It goes into a sintering oven, or you can use that unpolished piece. As I told you, electromagnetic radiation shielding, there are so many applications where you don't need to sinter it. So you don't need to spend that extra money in sintering it. After sintering, you can do polishing, painting, chroming, plating, whatever you want on the metal part. It's a pure metal part. You can do whatever you need, annealing. There are so many post processes which can be done on metal parts. So this is actually good for both metal, plastic, ceramics, this entire process. Or you can recycle or use it. And that's one of the best things. If you don't like the part, you can reuse or recycle it. All these things are recycled. Okay? So what are the advantages of this technologies? It's very easy to handle. They don't require specialized machines or anything. It's just a filament. 1 kilo, you can just carry it wherever you want. The capital cost of using it is very, very low. You don't need a very big setup. All you need is a machine and filaments. That's it. It's very easy to prototype, and there is a lot of design freedom. So you are not limited to thinking how the machine works and then you are designing it. Here you are designing it and then making the machine work according to you. So, and it's 100% recyclable material. That's again ease of production. So it's not just limited to 1 or 2 pieces. Now we are setting up farms where there are thousands of printers in a line and printing thousands of parts a day. So if you see Ultimaker, which is in your lab right now, it can be connected to the farm network and you can actually put hundreds of Ultimakers in one farm. And automatically the prints can be given to that particular printer. So applications, just summarizing the applications. Tooling is one of the biggest applications of this technology. To create specialized tools, jigs and fixtures, clamps and robotic parts. Robotic parts is one of the biggest industries, again we see coming up. Because it's not limited by how to use the technology, it is how you want to use the technology. One of the companies that actually everybody here should go and see in how they are using the technology is Boston Robotics. They have created robots which are just out of the world. Customized manufacturing, functional parts and prototypes, test parts and samples. So it can be any one of them. It can be a functional part which you want to actually use. It can be a prototype part. It can be a sample that you want to show to the customer and getting final output out of it. Design elements, artistic creation, statues and more. So it's not limited to just these. There are lots of other applications that you can use it for. As I was telling you, in the traditional technologies, you only get 100% solid inside. But if you see here, you can see the lattice structure. Now, this actually has been zoomed in thousands of times to show you the lattice structure. The actual piece is much intricate in design. So if you see one lattice structure, from here to here is 1 millimeter actually. And that's the beauty of 3D printing, because you can create very, very fine structures inside. Now, even though it looks like a golf ball, it is actually a thermodynamic piece for doing some thermal testing and heat flow and other testing. But the requirement of this was that it should have 1 millimeter by 1 millimeter lattice structure. And this is actually a core which has been cut after certain materials have passed through it. So you will see that it's completely filled inside, but it is actually hollow when you print it. So that is something which we think of when we talk about designs. You can think from inside out rather than outside in. This is a very simple design, but it is not as simple as it looks. Even though it's a character piece, if you look very closely at the rim, you will see there are micro pores in this. And that is to take away certain stresses which this particular designer had while making this part. Even though it just looks like a simple piece, if you take it to a traditional industry, they'll say, I'll make it in 5 minutes. But it's not possible in the traditional industry, because there are micro pores on the rim which you can't even photograph, it's that fine. This is of course a very traditional thing, statue making. And it's one of the biggest industries right now when it comes to this technology. This is a very simple application, but it was done for a designer who does not have any artistic inclination whatsoever. He does not know anything about art. And this was done by him. So what they simply did was create a mold on Ultimaker, put ceramic inside it, and they could come out with the art piece. So this is actually a vocational job creation workshop that we did, and these people don't have any idea about art. They have no skills at all. Now imagine if you want to give them some kind of a vocation or a job or some kind of a work. They will not have jobs. If you see the traditional pottery industry is slowly disappearing. And that is because of the lack of skills, not because of the need of pottery. It's because not everybody has the skill to continue their father's work. And they become bad at it and they start failing and then it disappears. To revive it back, it's a simple thing. You make a mold, cast it, and it's a very simple casting process. And this is a workshop which anybody can do. Even you can do just sitting idle. It's a really good thing, Pottery or clay work is very good actually. So it's very easy, but you have again got that industry back. And that's something which is very good. This is again one of the materials, BASF Ultrafuse 316. It's similar to Catamold, which everybody uses in the industry. And these are prints out of that. If you notice, there will be slots cut all around the parts, like these, which are not possible in the traditional industry. So you can't have side slots, a very deep gallery or a slide shot in a traditional industry. It will need a lot of processes to do that. And each piece will not only take time, but also will cost a lot. Over here, it's just a matter of printing. So you take a simple filament and you print it out. And it's that easy. So this is the capex or the machine that we have for doing this. We have a pellet extruder. Pellet is one of the oldest things that you find anywhere. There are lots of pellets in the world. There are more than 15,000 types of plastic, metal and ceramic compound pellets that is getting used in the industries. All you do is simply take those and you can create your part on one of our machines. Ultimaker, which is already installed here, is one of the most easiest machine that you will find, most easy machine that you will find in the world. And not only easy, it's a workhorse. You can literally run it continuously and nothing will happen to the machine. It's a sintering furnace. Don't go by the price here. This machine is a little expensive, this particular furnace. But what we need to say is, you can actually sinter our parts in a machine sintering oven which can actually start around 80,000 bucks also. But those are only for certain limited materials. Okay? So there's a lot of jewelers, for example, use a machine which is hardly 25,000 rupees. And they can simply print on our machines and center because they are using that particular metal which is centrable on that. Okay. One of the things which I showed you is the lost wax process. Remember, this particular company makes fan blades. It's a special blade actually, which is used in the boat industry. And 100% of this blade is casted after printing. So that's the print that you see, and that's the casting part. And why it's done like this is because depending on the size of the boat, the vanes angle change. And it was very difficult for them to open a mold for every boat that they were making. Because every boat has its own vane. And their warehousing cost was 3 times more than actually making the part. Because if they sold a boat to the customer, they have to keep the mold for 20 years. And the warehousing cost of those molds was so high that the part eventually landed up very costly to the customer. So around 2 years back, we tried with them this technology where we started printing on a special material called molding plastic. Okay, we simply print with that plastic, put it in the furnace, put the metal, and it becomes, the part. And after that, you just simply polish the part, you can trim it a bit, and that's it. So now they have saved literally thousands of dollars on their warehousing costs. They don't need to think about keeping any molds. All they do is simply print, cast, provide to their customer. And it's on demand. Because the printing of these vanes takes hardly 2 to 3 days. And casting takes 1 day. So the turnaround time has reduced from initially 2 to 3 months to days. And they can make different vanes for different customers now. It's design freedom, Now you can think of doing whatever you want basically. So all around their yachts, they have customized everything from door handles to whatever you can think of, including the ends on which ropes are tied. So it's a boating industry. So again, if you see across, there are lots of challenges which were solved over the period of our work time in different industries. And industry is such, and once you make a change in that particular industry, everybody follows the trend. And now we have lots of people in the yacht industry, the boating industry coming to us and saying, can you set this up for me? Because it makes a huge change in the whole economics of the company. This is just an example of what you can do. Right now, just at the face of it, we have more than 200 types of materials. And if you take the combination of these materials, in terms of every part, we have close to 15,000 SKUs, which means we have close to 15,000 combinations, which you can use to prototype something or to design something or make something. So you can do anything from wax, edible items, plastics, rubbers, acrylics, clay, sandstone, ceramics, porcelain, resins, silicon, metals, artificial leather, marble, human bone, and cells. So you can do prototyping with all these things. And that's a huge area that you see. So, when I talk about, design freedom, this is what design freedom means. You're not limited to something which you study in books. You're not limited to something which you think you want to do, but you are held back because you don't have the necessary tools. Today, it's very easy to get the tools. It's very easy to design, and it's very easy. Sorry. इधर तार नहीं आएगा उधर से. So usually when we do this type of a scan, the person will sit on a revolving chair so that the person revolves and the scan can take view from all sides. There will be a lot of space to move around. So there are some restrictions here, but yeah. So somebody asked me for the black color, right? So usually when a person is doing this scan, we will make them wear like a mat hat or something. So that will cover all the hair part, and then you can go to any software and recreate the hair. Anyways, when you are printing, you will not get a regular hair texture. So you can, it's like photo editing. So you can actually keep a set of hairs and just place on the person and then redesign. So it can scan hats and other things very nicely. So you can use any kind of hat to replace it.
Sir, in our industry, we usually use chalk powder.
Yeah, so you can use anything to make it like off black or shiny. There are methods in which you can take certain type of gray and shiny objects by increasing the intensity of the light that falls on the skin. That is possible, but then that's something which is which might not give very good results. So as you said, chalk powder, you can use spray. They are very fine powder anyway. You can use paint, white paint. You can use markers to create those same structures. So as you can see, moustache doesn't come. That is the area which you have to cover and replace it while you are doing this thing, or you can put stickers and then take that area and remove it later on. The powder which comes out from the parts are recycled again as fresh powder which can be used in the machine again. So there are certain videos attached which you can see on our website. It's very easy actually how to do everything.
Centered simplicity of professional 3D printing. Recovering the powder. Before using the device, it is highly recommended to read the full printed version of the user manual. Gather the powder using tools included in the set and transfer it to the printing form with the rest of the powder. A portion of the powder is located in the overflow bin. Take out the overflow bin and transfer the powder gathered in it into the form with the previously used powder. Sometimes, some powder may collect beneath the overflow bin. Remove it so that the overflow bin may be replaced properly. The remaining powder should be grinded down. In order for the powder to be suitable for reusing, mix it with fresh powder, which quantity is calculated by the Centered Studio. For measuring the powder, use the measure included in the set.
So what happens is whenever you run the machine, after the machine shuts down, it will tell you how much fresh powder to put or mix with the used powder. So the machine actually calculates everything for you. All you need to do is measure that much, put it in the old powder and you get a new powder. And it's very, very easy.
Centered simplicity of professional 3D printing. Taking out the print and cleaning it. Before using the device, it is highly recommended to read the full printed version of the user manual. After finishing the printing process, wait for the printer to cool down. The current temperature inside the printer is displayed in the Temp tab. It is impossible to open the lid if the temperature in the tank is higher than 50 degrees Celsius, 122 degrees Fahrenheit. Wait until the printer cools to below 50 degrees Celsius. But even when the temperature is around 50 degrees Celsius, refrain from cleaning the print until it fully cools. For cooling, open the printer, move the printer bed up, and leave the print for approximately an hour. Moving up the print bed, go to the Mechanics tab on the display and move the print bed upward. Depending on the print height and the location of the elements, the print bed should be positioned at the height calculated by the program. This way, the bed plate's bottom should be positioned at the tank height. Before taking out the part cake and cleaning the print, put on gloves and a mask, taking the part cake out. Before taking the print out, empty the overflow bin in order to make room for future cleaning of the printer. There are 2 spatulas for taking out the cake, a large one and a small one. Position the small spatula between the cake and the printer's wall. Place the large spatula on a feed bed and in a sliding motion, sweep the cake. It is recommended to clean the cake in a place where the unmade powder will be easy to collect, for example, a print form included in the set. Cleaning the print. Clean the print using the tools included in the set. The print should be cleaned as precisely as possible, as the recovered powder may be later refreshed and used for future printing purposes. Finally, the print should undergo sandblasting. Recovering the powder. Gather the powder using tools included in the set and transfer it to the printing form with the rest of the powder. A portion of the powder is located in the overflow bin. Take out the overflow bin and transfer the powder gathered in it into the form with the previously used powder. Sometimes, some powder may collect beneath the overflow bin. Remove it so that the overflow bin may be replaced properly. The remaining powder should be grinded down. In order for the powder to be suitable for reusing, mix it with fresh powder, which quantity is calculated by the Centroid Studio. For measuring the powder, use the measure included in the set. Sifting the powder. Next, we can start to sift the powder.
So this process is actually now automated. You can buy a sieving machine and you can do everything with it. So typically when you buy a sieving machine, there are options of buying the whole ecosystem, or you can just buy the machine itself. If you buy the machine itself, you will have to do everything manually. Otherwise, you can just put it in the sieving machine and everything will happen in the machine itself. So you don't need to do all these processes by yourself. The rest is just like cleaning the machine and reporting.
Sir, in this slide, can we also prepare a powder by your own? Suppose myself I have to create some powder. Then
Yes, you can do that. The first thing is how to do metal printing on Ultimaker. Okay. Then we have for you that's a ceramic printer. So you can also do ceramic printing on Ultimaker, but that's a different type of ceramic printing. Okay. So let's just see some of the functions of Ultimaker 5. This is the series S series. Okay. And what it has is a touch screen, very easy to use software, and a really large printer compared to the other Ultimators that we have. It's a closed, semi-closed environment. So with this, there are options to buy a cover, air cover, and a material station. So if you see the picture here, I'll just point it out. So this is the unit which we have. These are the 2 units which are being used now, which is the air filter and the material station. So what happens is, if you are printing large parts, you require more than one spool of printer, and then you are in a constant mood of tension. The moment that finishes, I have to insert another filament. Material station automates the whole process. And if you are doing multi-material printing, you can actually set it up like that, and you will take out the filament and use a new material automatically. So that's a new functionality which was added to this machine. And it's a really powerhouse right now. Okay. So very simple. Functionality. It has two nozzles. Okay, the nozzles are like clip-ons. So this is the nozzle. Okay. So that's the nozzle port which actually goes inside the machine. So if this is blocked, which happens during printing sometimes, all you have to do is remove this and put a new one. And you can just start your printing process. Otherwise, the whole printer is shut down for the process in most of the cases. This particular nozzle is called CC4 red, and this one is used for metal printing, ceramic printing, and abrasive printing. So printing with compounds like carbon fiber, glass fiber infused, or very high temperature material, you have to use this code. Okay?
इसका material
इसके टिप पे actually ruby लगा हुआ है. Yeah, actual ruby लगा हुआ है, so it's quite valuable that way. This is a bit expensive. I think the price is around 40,000 if I'm not mistaken. But this is one of the most expensive parts that you will find in your ventilator. And this is also really hard because even though it looks like a normal simple nozzle, but it actually has a chip inside which records how much printing time you have done and everything. And based on that, the printing flow is changed. So you always get the optimum print. Hota kya, when you start using the printer, the nozzle will slowly start expanding, and आप देखोगे कुछ prints बाद आपके prints अच्छे नहीं आते. And that's because the nozzle it's time to change the nozzle, and we never realize it because the change is so minimal that we only realize it when it becomes drastically bad. But this actually automates that process and kind of records how much prints you have done, and based on certain dynamics, it will keep changing the print parameters automatically. So you will always get a good print. That is one of the benefits of Ultimate. Everything is so automated in that. These are some of the parts which we have printed on metal. We will be doing some prints here, so you will come to know. But these are the parts that we have done. We have also polished one of the rings, so you can see how shiny it is. And typically you can polish everything in a tumbler, and it will become just like a finished metal piece. And if you put it in the furnace, which is just behind you, then it will become a pure metal piece. But let's say I was doing prototyping, I just want to see the looks, or I want to show somebody how it looks like. So it's very good if you just polish it, and if I don't like it, I just throw it back into the recycler and I can recycle it. So if you feel it, it's really heavy, almost like pure metal. This is bronze, by the way, so it has about 85% metal in there. So printing is very easy on Ultimatum. Vipin will actually show you how to print with Cura settings and everything. So you can increase setting Vipin print. So if you see, this is the filament, and it comes in 0.5 kilos, 0.25 kilos, and 1 kilo sizes. And it's just like a regular filament. So you just attach it in the back of the printer, and you just give it to the feed, and that's it. And it prints like a PLA. So PLA is the easiest filament to print with. It's almost like that. There is nothing else required to print it. And it's as easy as that to print with. Okay? All you have to do is pass it through a filament warmer which is attached to the back of the machine. And that's it. So it's that simple. And you can print all the metals like that, including stainless steel, titanium, aluminum. There are so many metals that you can print with this machine. So typically one machine solves all your problems. Similarly, we have ceramic filaments, and we are going to come up with some biofilaments also in the future. There are filaments which are used for making like peristaltic pumps, which are used like for making chemical safe fluid handling systems. There are filaments which are used for making like slider gears and other things. So there are filaments for every application, and it's a whole new world out there. All you have to do is go to the Ultimaker site. Under the partner program, you will see all the list of all the filaments, and you can select which one you like, and all the configurations are already present. So the moment you actually start Cura and select the filament, the configuration will get loaded onto the machine by itself. There are certain filaments like the Ultimaker's own filaments, which does not even require you to tell the machine what filament you are putting in the machine. It recognizes the filament by itself. So if you see here, it already knows that you have put a tough filament material. It has an NFC ready tag. So the moment you put the filament in the station or behind the machine, it recognizes that and it tells you that this is the material you have installed. So you can't actually go wrong putting the wrong filament, and every time you have to remember the settings. But this machine does that for you. So you don't need to remember the settings. It has got the settings for almost everything already inside. Also, what it does is it checks the type of nozzle you have put for the particular filament. So if you are putting, for example, PVA, which is a water-soluble filament, it only works with BB4, which is a support core we call it. And if you have put the wrong core, it will tell you that you are putting the wrong core. So you can't spoil the machine really, unless you really want to spoil it. Otherwise, it kind of has a mind of its own. It recognizes the filaments, it recognizes the type of file you're putting. And there is something called as adaptive printing. So it adapts the layer heights, it adjusts the layer height according to the print, which is something new as a feature in the machine and the software. That you can actually change the layer height during the print to adapt it to the features. Like certain features are so curvy that they require very fine layers. But then there are features which are straightforward and they don't need small steps. So you can save the time accordingly also by using those layers. Sometimes it happens during designing that we make certain parts but they are unprintable. That can be due to many reasons like thin walls, thin structures, unclosed holes and all of this. So there are features in the software to even do that, which allows you to close those holes or make the file printable. Okay. It also tells you where the supports are missing. So you can add the supports manually or using the software again to make it printable. So let's start something with Cura and
ठीक है सर. So to print the Ultimaker, there is a software called Cura, and now I will be telling you how to print, how to initialize your printing, how to start the printing process. So as you are already aware of the print course, there are three types of print course available. One AA, BB, and CC print course. AA is used for general materials, for PLA, for ABS, for nylon, for PC, polycarbonate, and with CC we will print metal filaments. And right now I will tell you how to print with metal filaments. Okay. So if you will see Cura, there are three options available here: prepare, preview, monitor. Prepare is an interface where you will import the STL file and give some settings. I mean the layer height and all, infill and the temperature settings and all. Okay, so next thing is preview. Preview is when your printer is connected to, monitor is something when your printer is connected to Wi-Fi, so you can monitor your prints. I mean, there is a camera over here, and you can see whatever.
So let's say you have more than one printer, and you are sitting somewhere in the room, you want to see what is getting printed. Or 99% of the time, you will be putting the prints at night. And the whole night you will be having a tingle in your brain that what if my print has failed, what should I do with the printer and stuff like that. So you can actually put it on Wi-Fi, use a mobile to actually track the print and see how it's printing. And if it doesn't print properly, you can stop the print from the house. So at least you will be saving on the printer and the machine time, and from cores getting spoiled or whatever. And you can also transfer the file if the machine is on and everything is set from your house. So by the time you come, maybe the print is ready, or it's already halfway printed. So there are a lot of features associated with such features.
Okay. So next option is, you can see over here, it's Ultimaker S5. So whenever you, whichever printer you are having, I mean Ultimaker S5 right now we are having. So you just have to click it here and select whichever printer, whichever version you are having, because they are the smallest one. If I will talk about, it's Ultimaker 2, and it's now latest technology. I mean latest one in Ultimaker is Ultimaker S5. So you just have to select that. And our next one is again the print course, whichever we are using, we have to give it over here. There are two. It's a dual nozzle printer, so you have to give settings for single, for extruder 1 and for extruder 2 as well. So if you will see, there are two options: extruder 1 and extruder 2. Here is 1 and here is 2. So for we are going to print with metal filament. We just have to select PLA over here, where we will be printing only with PLA settings, but we will be changing the temperature a bit and speed of printing. So from here you can select. I mean, if you are using ABS PLA.
Actually, right now they are not connected to the Wi-Fi. Otherwise, you can go to the Ultimaker marketplace and download the settings for printing with these filaments. It's available online, but just because we don't have Wi-Fi connectivity and we can't get those things. Okay? उनको पूरा set करना पड़ेगा. उनको time लगता है. The another thing is you can download plugins for SolidWorks. There is plugins for various softwares that allow you to directly print from those software. Like you can download the plugin and put it with SolidWorks. So from SolidWorks itself, you can give the print. You can just send the file for print.
We do that for that.
Yeah, so you can do that.
So in material settings, there are various of filaments available. In generic means if you are using any third-party material, like and if you are using Ultimaker original filament, you can just select over here Ultimaker, and if you are using ABS, it's available in these colors: blue, gray, black, orange. You just have to select it over here, and the temperature settings and all will take automatically. You don't have to set your settings. I mean, if you are using third-party filament, then most probably you have to set, but we will recommend. Sorry? Okay. So in this tab, you just have to select filament, whichever you are using. If you are using any generic material, to select generic. From generic, you can select ABS, PLA, and you can define your own settings as well. In the setting, we will come to that point as well. Okay, so right now we will just select PLA for printing with metal. It's already selected. So we have defined for one extruder till now. We have to define for another one, but we will not be going to use that, because with metal printing we just make sure that there are no supports in the object. We can make the support with the same metal filament as well. But most probably second extruder you will use when you are printing with PLA and PVA. It's a water soluble material, PVA. Okay. So with slot 1 we will be using CC print code and metal filament. And for metal filament we will be selecting here PLA. And now next step is, in next step you just have to give your setting. First one is layer height. So it's a height of one layer only. It's a layer by layer formation. So it's a height of one layer. So you can define 0.1, 0.2. 0.1 is most preferred one. You get success is really very good at 0.1 mm.
So layer thickness will be height
Layer thickness.
Wall thickness very good. Concept of wall.
थिकनेस लेयर थिकनेस की बात कर
That is layer height.
Layer thickness again depends on the nozzle diameter as well.
Vertically we are lying the layer. This is the thickness. अगर क्रॉस सेक्शन वाले देखेंगे ये जो विंडो है
नहीं थिकनेस नहीं होगी,
नहीं वो
ऑटोमेटिकली काफी
वो तो मल्टीपल कंट्रोल्स लगा सकते हैं you can want to increase that but वो नहीं चाहिए
पर आप टॉप बॉटम हाइट की थिकनेस दे सकते
हाँ वो देख
पर ऐसे वो भी वैल्यू कर सकते हैं ना, अगर हम 0.8
हैं. So you can do adaptive printing as I told you, that for things which need high accuracy, you can set that up and that will go at very fine layers, and where it doesn't need it can go like 0.25 mm layer length also. So that's an inbuilt thing in the software.
So next is again the same thing, cell thickness is the wall thickness of a part. A part is consists of a wall thickness and an infill. And infill is something a cross section area inside a part. Suppose if you are making a cube and you have given a 15 infill, 50% infill, it will not be a solid one. It will make a cross section inside the after the walls of the. I will show you in the G code.
You have a lot of options of how you want to fill inside. So either you can leave it 0, which means not a shell. Then you can make honeycomb structure, you can make straight curve structure, you can make spherical structures. All these are already there. You can make a zigzag structure. So you can actually fill the inside with, that is what I was talking about, to save the materials. Okay? You can also decide on how much infill you want, what type of a pattern do you want, and the biggest thing is you can change it also. So in a big part, you might want that a certain part to be having less infill. The other one, by the time you reach the top, you want a little more infill so that you get a better quality of output. So that you can do in the software. So the software is like really powerful.
Okay. So inside, if you will see the yellow lines, it's infill. Okay. And if you will see the green and the red one, these are the cell thickness.
So in the software, there are also some quick settings, which is fast print, normal print, and good quality. So they have already given you like some quick function. If you don't want to go ahead and set the things yourself, simply select the filament code, press the fast button, or it's like a quick move. So you don't really need to go ahead and change every parameter yourself. It has a kind of a quick parameter settings. So that really allows you to do quick work. And somebody who has very little knowledge, you don't need to go into the advanced mode at all. You just press the button and magic will happen. Then there are lots of experimental scripts which you can play around with. Like suppose if you want to print wire, like a mesh printing. So you actually design the thing solid, but in the software you can go and say, I want to print it like a mesh, and it will print like a mesh. But those are things which we advise you to do after a little bit of
infill like.
So by setting those, you can get really interesting parts out of the machine.
This one is a PLC.
Can we dim the lights?
Light for the machine. Machine will light from the, but people will not be able to see inside. It become very you can dim the light, you can switch it off also. Another thing is that both the cores are on a moving track. So if one core comes down, the other one goes up. It's like that. So normally on a 2-core printer, what will happen? One core will just keep touching the prints and spoiling the prints. In this, it goes up. So you have typically printing with only one layer. There is a feature where you can also create like a cleaning block for cleaning the core before you start printing with it. So it automatically creates like a block for cleaning it. There are lots of features which are there, which you can start using as an advanced user and really take advantage of this.
सपोर्ट मटेरियल तो नहीं चाहिए था
हाँ जी।
सपोर्ट मटेरियल चाहिए था
सपोर्ट मटेरियल अगर आपने, if you want to print with support material, then you should use support.
अदरवाइज मशीन की रिक्वायरमेंट नहीं
नहीं, certain parts that can print without support.
सपोर्ट क्रिएशन के लिए मैनुअली अलग सॉफ्टवेयर में पड़ता है इसके सॉफ्टवेयर के साथ
The software actually creates support for you. Not only that, you can also create support of different types. There is a grid support, a line support, a spherical support, a cylindrical, conical supports. All these things are tree-like supports. So there are lots of types of supports that you can play with. And what it allows you to do is very, very powerful. Like there are experimental modes. You can even script if you like scripting. You can script your own modes. Yes. So machine will show you all the overhangs like a red portion, and the software. Then it's upon you whether you want to print with support or not. But there have been places, times when I have actually printed things when it was showing there and it has printed. Yeah. So usually what will happen is, just to tell you, like for example, in this object, we can print all these parts without supports, even though the software will tell you to put supports. But you can connect these. Now if I cut this out, you will see that there are hanging structures inside. And why? Because when the first layer is formed, it will actually sat down like a U shape. And that becomes the base of the support for the next layer. So slowly, with every progressive layers, that hang will keep reducing, and this is the final output which you get. So even though in the final output you are not able to see those defects, that hang is still inside. But it does not matter to me because the part is completely closed from outside, nobody is going to see it. You understand? So you have to decide yourself how you want to use it. Another thing that we do is, it's like a test also, where you can print like small ladders with overhangs on top. So you can see what is the distance where you don't need a support to print and design accordingly. Like if you are printing, for example, an arch, you don't really need a support to print an arch. So you can use all these features to actually design when you are designing. It really helps you to design. So there are lots of test prints you can see. There are on Thingiverse, they're everywhere, where you have to print these steps, these cones, which allows you to actually understand at what distance I don't need a support, at what angle I don't need a support. And after that, you just start designing accordingly. You can also change certain features of the machine, like the values of the machine, by slowing it down to see whether that support is printed nicely at that speed or not. So there are lots of things which you can actually do, on your own. Right?
So first we will start by changing the print code from AA to CC print code. So we will place this in slot 1.
So we just have to select here.
A is written over there. I mean the configuration of both the extruders is written over there. AA and A. And there is 3 options: load, unload, and change. So we will select change. So it will take some time. You just have to follow each and every instruction on the screen. We will guide you with each and every step. Now it's saying carefully open the print head fan bracket and confirm when completed. So this one is print head fan bracket. You just have to open it like this. Then you have to confirm. Now it's saying remove the print code. Now you can remove it. You just have to press it like this. See the layers stay over here. And you just have to press it like that and just put it. If anybody wants to try, can come. So next thing you just have to insert it. Press it and then push it. Then confirm.
और वो जगह पे ये प्रिंट पर
So yes, next we have to load the material. So there is an option of material and material for one for first extruder and material for second extruder. You just have to click here and load.
Mesh. Yeah, so this is basically one of the prints which is given not from ultimate though, but you can still see the structure inside.
So there is spool loader at the back. You just have to place it over here. And so there is an instrument at the back. So there is an instrument at the back. We call it warmer. So there is a tube like whenever we are using metal plant, then only we will be using this instrument. We are just have to make sure that this will be heated a bit before going to the extruder. So the temperature we set is 60 degrees. So it same place the new school they have done it. It's asking for the for material setting for whichever material you are inserting. So we just select PLA. We just have to insert a bit from the back. There are two feeders. So next thing is you just have to wait till material come out of the nozzle. Then you have to press confirm, otherwise it will stop here. Some materials also.
Bronze. अभी जो आपने लोड किया था ब्रॉन्ज है, बट आप टाइटेनियम से भी प्रिंट करेंगे इट विल बी द सेम प्रोसेस. आपको एल्यूमिनियम से भी प्रिंट करना है इट्स सेम प्रोसेस बिकॉज़ जो बेस बाइंडर है दैट्स PLA.
Temperature will be different for all these.
नहीं, while printing the temperature is just like PLA. Furnace का temperature will be different when you are centering it, but printing के लिए it's the same for any material, any material. And that is the beauty of it, because आप चाहे ceramics print करो, चाहे aluminum print करो, चाहे कुछ भी print करो, आपको कई चीजें नहीं यूज करनी यहाँ पे. Furnace में of course centering temperature क्या होता है, हर चीजों का अलग होता है. एंड वहाँ पे मेटल के हिसाब से फर्नेस उनकी एनवायरमेंट भी अलग होती है हर चीज के हिसाब से. So that's a completely different game plan altogether. But printing process we have standardized. So once that is standardized, that process is anyways different even in the general industry. You know? So it is actually already started extruding. So it takes out little bit of filament to peel the dirt of the nozzle. जैसे आपने कभी कोई ABS में या printing कर रहा है पहले PMA में, तो थोड़ा सा extrude करता है, इससे वो नहीं करता है, फिर वो अपनी process चालू करता है. Yes, so it is different for different. क्योंकि वो पहले उस जो आपने पिछली मटेरियल लगा रखी है उसके टेम्परेचर में जाता है, वहाँ से थोड़ी सी एक्सट्रूड करता है, फिर मिड टेम्परेचर में जाकर एक्सट्रूड करता है, सेम लेवल प्रोसेस. That is, I was telling sir, even today, yesterday also, the more you use the machine, the better it starts becoming. Because when you are using it every day, you know, it knows, it has more data to start better. जैसे आप उसको रोज अगर सिर्फ PLA प्रिंट करते हो, तो उसको इतनी मेहनत नहीं करते हैं कि स्पीड प्रिंट किया होगा. So actually, what this machine does is, before every print, it checks the alignment of the bed with the nozzle, and that is a process which takes about 10 to 15 minutes. So we just bypass that.
Input sources can be very well Wi-Fi.
So you can send by Wi-Fi, LAN, and
उसका क्या है?
उसका SD कार्ड है.
Printing temperature कितना सर है?
For this one, it's roughly about 200 to 220. 180 से 220 के बीच में आपको.
But it is a great with 1923 at 27. But in case of copper, the printing temperature.
So again, when I explained to you, we are not looking at the temperature of the material like copper or the metal. We are looking at the temperature of the binder while printing. Because जितने भी दूसरे machines हैं, उनपे you have to consider the temperature of the material you are printing. Okay, and that makes it very difficult. यहाँ पे printing process is standardized.
Using as a filler material temperature.
Yes. So you are only concerned with the binding temperature because you are melting the binder to give the shape of that metal. So the binding temperature is PLA. So you just simply print like a PLA, and then you can sinter it like the metal. So then you have to think about lead and ammonia and stainless steel. As a stainless steel, you have to go into higher temperature. Aluminum you can do around 800 to 900 degrees. Bronze is another 800 to 900 degrees. So something like that. So sintering over that will happen according to the sintering method. Printing happens according to the printing method. So the printing PLA projects will with metal finishes.
बेसिक कंसेप्ट है तो जब हम लोग मैटेरियल को तो एक्सट्रूड कर रहे हैं और बाइंडर से आप लोग ज्वाइंट कर रहे हैं, यही प्रोसेस है इसके अंदर. या तो जो एक्सट्रूड करने के लिए टेम्परेचर है जो इनका क्वेश्चन था, वो तो मेटल टू मेटल डिपेंड करेगा.
नहीं, क्योंकि आप मेटल को ज्वाइन नहीं कर रहे ना, मेटल को एक्सट्रूड कर रहे हैं, तो मेटल तो एक पार्टिकल है जिसको निकलना है बस. जो मेल्ट होना है वो तो प्लास्टिक है.
बाइंडर का तो आपने
बाइंडर जब मेल्ट होता है तो उसके साथ में प्लास्टिक अपने मेटल को भी लेके आता है.
एक्सट्रूडिंग टेम्परेचर
Expansion में भी
Yes, but PLA has very little expansion.
मेन सर हमें पेस्ट बनाना है मेटल का ताकि एक्सट्रूड हो.
मेटल का पेस्ट नहीं,
फिलामेंट
PLA है, उसके अंदर स्मॉल पार्टिकल्स हैं जिसके
मेटल है
और वो PLA को मेल्ट करना है.
आप ऐसा देखो,
we are not melting the metal.
so you are not actually printing metal, you are printing with metal particles, and the binder is a plastic. Yes, but when you sinter it,
That is
the plastic burns away, leaving your part completely sintered as a metal part. and that is where it also fuses, all the particles fuse with each other. तो उस समय shrinkage होती है, उस समय about 12 to 21% shrinkage भी होती है. Exactly like that. So basically हमने क्या किया है, जो आपका जो प्रिंटिंग प्रोसेस है उसको स्टेबलाइज करते हैं. फिर सिंटरिंग इज अ very old technology, everybody kind of knows about it. So now it is just following the chart to center it in a particular step and getting the final result.
सर इसमें अगर बेकिंग वर्ड यूज करें ज्यादा सही नहीं सिंटरिंग के लिए.
बेकिंग नहीं होगा, बेकिंग मतलब
सिंटरिंग इज पाउडर को प्रेशर हाई टेम्परेचर में प्रेस करके ओवन में रखते हैं हाई टेम्परेचर.
नहीं, सिंटरिंग is when you fuse two things to make it one piece. So what we are doing is taking very fine particles of powder, removing the binder and fusing them. So actually क्या होता है, जब वो दो particles fuse होते हैं तो एक तरह से shrink होता है, और वो shrink uniformly हो, इसलिए उसको हम एक रिफैक्ट्री में डालते हैं, जैसे ग्रेफाइट हो गया या बहुत तरह की रिफैक्ट्री आते हैं जिसमें हम उनको डालते हैं, एंड ऑक्सीडाइज ना हो मेटल. इसलिए वो जो फर्नेस हमने लगाई है उसमें आपको ऑप्शन है कि आप उसमें ऑर्गन या नाइट्रोजन भी इंसर्ट कर सकते हो इनर्ट एनवायरनमेंट बनाने के लिए, एंड दैट्स अ वैक्यूम फर्नेस, तो वैक्यूम भी कर सकते हो उसमें. सो बेसिकली व्हाट यू आर डूइंग इज कंप्रेसिंग इट एंड फ्यूजिंग देम मच प्रिसाइजली. नाउ वेयर इज द एडवांटेज इन दिस? आपके पास यूनिवर्सिटी है, यू हैव फंड टू बाय अ फर्नेस. Let's say a student does not have the affordability of a furnace, right? You can simply buy the machine, buy the metal, print with it, then take that print to a furnace guy and tell him center.
मोशन तो किसी भी लिंक के बीच में रिलेटिव वेलोसिटी नहीं आनी चाहिए, नहीं तो रबिंग हो जाएगी. रबिंग होगी तो वेरिएंट टियर बढ़ जाएगा. अगर मैं इसका देखूं, अगर मेरे इसके स्टेट सेटिंग्स एक्चुअल एक पॉइंट पे फिट नहीं कर रहे होंगे तो क्या होगा, मेरे इसका मोशन ये वाला पार्ट है जो और घूमेगा, ये वाला मोशन इस टाइप के मोशंस को स्टडी करने के लिए आपके पास अगर ये 3D मॉडल है तो आप एक एक्चुअली कॉम्पैक्टनेस चेक कर पाएंगे, डिजाइन की फिजिबिलिटी चेक कर पाएंगे, और उसके मोशन की स्टेबिलिटी भी चेक कर पाएंगे. एक्चुअली हमारे साथ हुआ है 48 लोगों ने सिस्टम डिजाइन किया, सब कुछ हुआ, लेकिन मैन्युफैक्चरिंग फिजिबिलिटी ना होने के कारण उसके इंस्टेंट सेंटर्स कहीं और मेक कर रहे हैं. अब हमारा सस्पेंशन एक राइट्स वाला सस्पेंशन रिजिड हो गया. क्यों? अब उसका मोशन ऐसा सिस्टम हो गया हमारी गाड़ी का, जो क्या थी इंडिपेंडेंट सस्पेंशन को डिपेंडेंट होता है. ये कॉम्प्लेक्सिटी आती है डिजाइन. तो इन सब चीज़ों के लिए और ये सिंगल थ्रेडेड पार्ट इट इज नॉट अ मल्टी. एक बार एक सिंगल आप एक्चुअली में क्या होता है, देखिए जैसे कि जब मैं डिजाइन करता हूँ इस टाइप का तो मैंने ऐसे इम्प्लीमेंट किया हमेशा टॉलरेंस में. आप वहाँ पे क्या करेंगे, जब आप वेट करा रहे होंगे तो आप टॉलरेंस दोगे, या अगर वेट किया तब तक आपका पार्ट असेंबली नहीं बनेगा. लेकिन हम यहाँ पे हर जगह पे क्या कि भाई आप इतना एलिमेंट ओके तभी टॉलरेंस सेट करनी पड़ती है कि जैसे मैं एक माइक्रोन के लेयर को एलिमेंट कर रहा हूँ या 2 माइक्रोन. फिर उसके बाद क्या होता है कि ये पार्ट जैसे ये बनता है लेकिन मैन्युफैक्चरिंग के टाइम पर किसी भी चीज़ का टाइट फिट नहीं सकता. क्या आप मानते हो? और कोई भी चीज़ की आप परफेक्ट डायमेंशन नहीं अटेन कर सकते, ये भी हम मानते हैं. तो टॉलरेंस लिमिट के अंदर हम उसको प्लस माइनस करते हैं. जैसे कि आप जैसे कि शायद बड़ी ना हो, लेकिन हाँ जैसे कि जब मैं इंडस्ट्री में था तब मेरे को ड्राइंग्स के हिसाब से करना पड़ता था. हमारे